Welcome everyone to the next lesson of the full-time GoDev program, and in this lesson we're going to learn about context in Go. Package context. It's a standard library package, and it's getting used a lot in third-party libraries. It's used a lot at companies. You should know everything about package context, because you're going to you will come across context a lot, and if you don't know why it's needed and how to use it, you're in a bad spot, and that is something we don't want. So we are going to have an example, and it will be much clearer because we're also going to use it in our projects, right? So it's very important you guys have some kind of a good understanding about package context, right? So basically, why do we need context? So let's say, let's make a function, and we're gonna say that this function is going to be third party fetch value. Something like that. Is that clear enough? Not quite sure. Third party fetch value. So what I want to do is this is going to mimic some function that's going to do something. For example, third party, HTTP call. I don't know, something like that. Maybe we're going to change it up, right? And this third party HTTP call is going to return us, for example, a value, which is going to be a string or something, and an error, right? Something like that. So what is this? What this function is going to do, it's basically going to mimic some kind of an API call, some kind of a library that will fetch something from the network, from a backend or something, and it's going to return a value. And you're going to use that third-party function to enrich something in your code, right? For example, you're going to use a Stripe call, you're going to use something to fetch an image or something inside of your code base, right? And the problem is, let's return actually, we're going to return some values. We're going to return some value, some response like this, some response, and no, I'm not going to return any error in this case, right? So, two things can happen with this function, right? You can see, or actually three things can happen. Or we're going to get a result, which is going to be a string, or this function is going to fail, and that will return an error. But something else can happen, and that's that this function is basically taking too long, right? Because if you want to make, for example, let's say, let's call this function, let's mimic some HTTP round trip. And what is an HTTP round trip? An HTTP round trip is basically a round trip that happens from your computer to the API, to the server you're going to call, and then the server is going to respond, and the value will come back to you, and that is called an HTTP round trip. And normally HTTP round trips have some kind of latency, and that depends, right? If we have something around 100 ms of latency, that's kind of okay, right? Most likely it's gonna be 80 or 90 or 70 or something milliseconds that it takes to get a value from an API or something, but it can take much longer, and that's also a problem because sometimes we don't want that. Right? We don't want that. So how do we handle that? Well, let's first of all mimic this HTTP round trip. So we're going to say time. We're going to sleep here, and we're going to say millisecond actually. Time.millisecond, and we're going to wait here, let's say 100 milliseconds, right? That's an okay-ish round trip, right? An okay-ish latency. So we're going to say that the result here, the result error is going to be third-party HTTP call, right? And if there is an error that is not null, we're going to log fatal out this error, right? And otherwise, we're going to print out, what's going on here? We're going to say the result or the response of our, of our call, HTTP. Actually, to be honest, the response is fine. The response is going to be the result here, right? That's what we're going to do. So let's time this function out real quick so you guys already know how to do that. So we're going to say, for example, start is going to be time now. And then we're going to say the response is going to be, let's make a printf, by the way. So we're going to say the response took %f. And then we're going to say here the result itself, maybe a plus v or something for super verbose. And we're going to say time since start, right? And the result. So basically time since is going to calculate how much time it took since the value we actually initialized our time, the start, right? Very simple. So let's do go run main.go, and then we're going to see that the response took us 100 milliseconds and the response is some response. And basically I'm going to change this to, we're going to do user ID 200, user ID 1, for example. I'm just mimicking stuff, guys. I hope it makes sense what we are doing here. And actually, maybe I'm gonna implement something real. Maybe that's a good idea. That's actually no bad of an idea to make it some kind of a real. We're gonna say this. The response is going to be this thing. Let's run this again, right? So we can see the response took 100 milliseconds and the user ID is 1. Maybe you're gonna fetch a user ID something from I don't know, from some third-party shenanigans, right? That's fine. So, but what happens if we're gonna bump up this latency? Let's say this is gonna take 500 milliseconds, right? We're gonna make this 500 milliseconds and we're gonna run this again, and you can see that it takes much longer, right? It takes us 500 milliseconds, but we don't want that. We want a user experience of 100 milliseconds, and if it takes longer than 100 milliseconds, we want to cancel the request because maybe it takes forever, right? Who's going to tell us that? Then, because we don't have control about third-party libraries, about third-party functions. If we call Stripe, who is going to guarantee us that Stripe will respond? Maybe it takes 10 minutes to respond. Who knows? And we don't want that because our application is not going to wait for 10 minutes. So we need to find a way to handle that if our request is going to take longer than that we want, that we can cancel it, that we can handle that, all right? Because if this is going to be, for example, 50,000 like this, right? And we're gonna, what's going on here? And we're gonna run this. You see, our program keeps hanging, right? And the user is waiting for his response. Nobody wants that. So we're going to cancel that. So we're going to say 500 is fine. So how are we going to do that? Package context is going to save us, right? And how are we going to implement that? So basically, this is our third-party HTTP call that we are going to call from a third-party library, right? So then we're going to make our own function, and that's going to be fetch user ID, for example, right? Fetch user ID. And a fetch user ID is going to return us a string. In this case, it's a little bit nasty because an ID is most likely an integer, but hey, in this case, it's a string and an error. That's our function, right? So what we're going to do is, first of all, we're going to make a context. We're going to say ctx from context, a cancel, right? That's very important. I'm going to explain that soon. That's going to be context dot... you could do context.background, context.todo. That's basically bad practices. That's placeholder stuff. What we're going to do is we're going to make a context with a timeout. We're going to say with timeout. And then we can specify how long we want this context to be valid, right? How long, what is the maximum amount of duration this context can take? And we are going to say time.millisecond times 100, right? That's basically the maximum. We don't want any longer. If the function is going to take longer than 100 milliseconds, we're going to cancel that stuff, right? So the next thing we're going to do, this cancel here, is very important. That basically means that we could cancel it manually, right? It's going to get canceled after 100 milliseconds, right? But if we want, we can also cancel it manually. And a good practice is to make a defer statement with cancel here, right? And it's a function, so you need to call it like that. That basically means that no matter what happens, if this function is going to return, always cancel. And that will prevent us from having leaking Go routines or leaking stuff. Because maybe we're going to pass this context value. Maybe we're going to pass that into other functions. And these functions are depending on that context. So we need to make sure that everybody that depends on that context and this function returns, which basically means that this context is not valid anymore, we cancel, and everybody that's basically depending on that context, listening on that channels, is going to get canceled and everybody can clean up, right? That's the main goal of this cancel. All right, so what we're going to do is we are going to make a go function here, go func. And inside of this go func, we are going to call our third-party HTTP call, right? So what we're going to say is we're going to say that the result error is going to be third-party HTTP call. And what we're going to do is, because we're in, this is actually it's already advanced, guys. So stick with me. So we are in a go function. So what we need to do is we need to make a channel so we can, because you guys already learned this in the previous episode, in the previous lessons, that we are in a Go routine. So we need to find a way to communicate the values from this Go routine to the main function here, right? How do we do that? Well, we do that with channels, right? So we're going to make a type here, and we can make a type inside of this function. Why not? And we're going to say type result is going to be a structure. And we're going to say that we're going to have a user ID, and that's going to be a string, and an error, which is going to be an error, right? This is going to be our result here. And maybe we're going to call this res, right? So what we're going to do is we're going to make a result channel. So we're going to say result chan is going to be make me a channel of a result of this type here, of this struct, right? And we're going to say 1, right? Because we're only going to make one result. And then we're going to say here, when we have our HTTP, our third-party call here, what we're going to do is we're going to say that the result channel, we're going to make a result. We're going to write a result into this result channel. And we're going to say that the user ID is going to be this result here, right? This result is going to be our user ID. Look at this. It's going to be this user ID here, right? So we're going to say that this is going to be the res, and the error is going to be the error, right? I hope that makes sense. Let me do this. Yeah. So we're going to call our third-party HTTP call. That will return a response and an error, right? It's this function here. It's going to return a string or an error. We're going to make a new result channel, and we're going to write a new result, this result from third-party HTTP call into that channel, right? That's what we're going to do in the side of this function. And then, so we're going to fetch user ID. We're going to spin up a new Go routine. That Go routine will basically start making a call, a third-party HTTP call, right? In a non-blocking way. And then we're going to select, right? Because what do we need to do here? We spin up that Go routine. It's fetching the user ID. What do we need to do? We need to select. There are two possibilities that can happen. Or we are going to have a response. This one here, this result channel. Or, think about this real quickly. Or the context is cancelled, right? Or the context, or we are basically spending much longer than 100 milliseconds. So how do we do that? Well, it's very simple. We're going to say case ctx.done, right? And ctx.done is basically a channel that will tell us that this context is either, the timeout is either exceeded, right? So we're going to say done. That basically means the context timeout is exceeded, right? Or the context has been manually cancelled. And that's going to be another thingy, cancel. Right? Remember this cancel? It's this function here. You know what I mean? That will happen, right? That will happen in this case. So each time the channel CTX done is being triggered means or the context is exceeded or the context has been manually cancelled. So what are we going to do when it's cancelled or it's exceeded? Well, we are going to return nothing, right? Because we are going to return a string here. You see, fetch user ID string. So we're not going to return a string in this case, but we are going to return an error. And you could make your custom error, or you could basically say ctx.r. And that will basically return the error from the context. And you will see what that will be. That's the first problem that can arise. The second is, there is no problem. So that basically means that we are going to have a result, and we're going to read from the result channel, right? And we are going to return the res.userid and the res.error. That's what we are going to return. And what is this? Context with timeout. We also need to make a new context here. We're going to say context with background. Don't worry about this. It's fine. With background, context background, this one, right? That basically means each time you're going to create a new context, you need to provide a parent context. And if you don't have a parent context, you can make a new one and you could say context.background. That basically means make me a new context, a new parent context. Look at this, right? We're going to check this here. It returns a context. It returns a new empty CTX, a new empty context, a new empty parent context, right? Cool. So let us recap this function, because I can understand that this is going to be a little bit of confusing, but we need to get through this. It's very important. If you understand this, guys, it's very important. If you understand what's going on right here, you understand more than 80% of the Golang developers already, and you do not even started the project yet. So this is a very important thing. So let's recap the whole shebang real quick. We have a third-party HTTP call, which is basically a function that's going to get called from a third-party library or something else, or it's going to fetch something from Stripe. It's going to make an external call where we don't have control over how long it's going to take because it's not our server. It's somebody else's server. It could return in 100 milliseconds. It could return in 2 days. Who knows? We're going to make our own function, is fetch user ID. We're going to make a context, and that context has a timeout of 100 milliseconds. That basically means that everything that takes longer than 100 milliseconds will be cancelled. That's the maximum amount it can take. We're going to make a result. We make a result channel of this type result. We spin up a new Go routine where we are going to fetch our HTTP call. If that HTTP call is going to return, we're going to pipe the results. We're going to write the results into a result channel. Then we're going to select, because this is a non-blocking call. Then we're going to select, because two things can happen. One, it takes longer than 100 milliseconds. If that's the case, CTX done. We're going to return the error of the CTX, the error of the context. Two, if the context has been cancelled manually, we're also going to return that error. On the other hand, we have a result channel. So it basically means that this is happening before 100 milliseconds. We're just going to return the user ID and the error from that result channel. And that's it, right? So, yes. So what we're going to do now is basically, we're going to say that the user ID error is going to be fetch user ID, right? And if there is an error, and that error is not nil, we are going to return, we are going to log fatal out this error here, right? And then we are going to return here the response to yada, 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 and it's going to be the user ID, right? Cool. Let's run this, right? Let's run this. So we have 100 millisecond maximum. It can take maximum 100 milliseconds. And this is going to take 500 milliseconds. So what's going to happen if we run this code? What do you think? Boom, we got an error. And what is the error? Context deadline exceeded. Makes a lot of sense, right? It makes a lot of sense. Now we have, instead of waiting forever, instead of waiting 500 milliseconds, instead of waiting 5 minutes, we now have the possibility to get an error when that happens. And now we can handle the error, right? Now we say log fade loud, but you could do something else. You could try again, or you could make another, your backup server, I don't know. You could do something else. But before using context, we couldn't. We're just waiting like stupid monkeys, right? But not now, right? So what we're gonna do is we're gonna change this time sleep, and we're gonna say this is only going to take 90 milliseconds. Hey, perfectly fine, right? 90 milliseconds, that's what we want, below 100. Let's run this again. Boom, and now we have a response. And the response took 90 milliseconds, and the response is user ID 1. That's how context is getting used 99% of the time. And all the rest of the context, forget about it. Well, forget about it. What you could do in context also is basically set some values, right? You could set some values. For example, what you could do is, for example, look at this, what we're gonna do. What we could do is we're gonna say CTX, fetch user ID is going to take a CTX, right? It's going to take a context here, right? And instead of making here a background context, we are basically going to delete that, and we're going to pass in our own context. The context that's getting passed here, right? Crazy, something happened outside. Anyway, so what we're gonna do, you see fetch user ID, not enough arguments, that's true, because we're gonna make a CTX, right? And we're gonna say context with value, right? I need to double check what that is. We're gonna say a parent key and a value, that's fine. Main. So we're going to say a parent context, which is going to be a context background, right? That's how you make a parent context. And then we're going to say, for example, foo. Actually, to be honest, user name is going to be Anthony GG, something like that, right? So now we're going to make a context, and we are going to provide some metadata inside of that context. It's very important, because if you are passing this context in Go routines, we already know that Go routines are basically prone to data race conditions, right? But if you use a context and you set the values inside of that context, it's safe to use inside of Go routines. So that's actually amazing, right? So we don't need to worry about data race conditions here, right? So what we're gonna do is, so we have the CTX, we're gonna pass the CTX inside of here, right? In our fetch user ID. And the cool stuff is that right now in our fetch user ID, what we could do is something like, it's a good question. You could do val is going to be ctx.value. And we're going to give this a key, and the key is going to be the username. And then we could actually print out something like the value equals val, something like that. Let me see if this is gonna work. Going on here. You see, the value is Anthony GG. So that's how you could basically set some variables, set some keys and values inside of your context, and use them somewhere else in another function, right? That's also something you can do. And these two things, basically the timeouts and the setting the values, are basically 99% of the time you're going to use context. Yeah. So that's basically it for context. This is actually a very common example. This is basically a very common use case, right? And I think you basically know everything you need to know about context. I'm not gonna lie. Are there any more questions? Feel free to comment on the video to discuss in the Discord channel. It doesn't, don't hesitate to come up and ask me your questions if something is not clear, right? That's the whole package, right? It's inside of Full-Time GoDev. You can ask me questions. The main goal is to get you kickstarted as a full-time GoDev engineer. Thanks for watching this lesson, and I see you in the next one. Peace.